Good evening, everyone. Thanks for joining. Let's wait for 5 more minutes. Let's others to join. Thank you so much. Hello, everyone. Good evening. Am I audible? Anyone please reply?
Yes, sir.
Yeah, thank you so much.
Yes, sir.
Thank you so much.
Yes, sir.
So,
Good evening.
let us start. Let me give a broad introduction. So, I am Saravanan, Prime Minister Research Fellow of NIT Tiruchirappalli. I am from Department of Civil Engineering, and my research area is landfill mining, that is on solid waste management. I am from environmental engineering background, and a small introduction about me. I have completed my BTech in Civil Engineering from Government College of Engineering in Theni in Tamil Nadu, and my masters from Anna University. You may all know about this in Chennai in environmental engineering, and I have joined the National Institute of Technology Tiruchirappalli in 2021, and I got the Prime Minister Research Fellowship in 2022. As a PMRF Scholar, I have to show the website. You can see pmrf.in, and it is a prestigious fellowship given to the research scholars across India. And this is one of the fellowship. You will get lots of contingencies, and you will get lot of contingencies and grants. So that's the motive of this PMRF program. And every year they will select 1,000 scholars across India from notable institutes like IITs. And NIT Trichy is the only NIT to receive this PMRF fellowship. And you can see all other institutes here. Those who are getting the PMRF fellowships, all IITs plus NIT Trichy, and some notable institutes like Jamia Millia and University of Hyderabad, University of Delhi, and all. So we are getting a research grant of around you can see here the guidelines. Um, Um, yeah, I think that's not in the home page. Oh, here. So every year every month we'll get a stipend of 70,000, and in the third year we'll get around 80,000 per month, and apart from this we'll get a contingency of 2 lakhs per annum as a research grant. For this we have to take at least 2 hours of week teaching assistant in nearby schools or colleges or in NPTEL. So as a part of PMRF deliverable, I am taking this course NPTEL wastewater treatment and recycling. So I have also taken other 3 courses in NPTEL. That is, in the first 2021, I have taken plastic waste management. Then I have taken air pollution and control, and then integrated solid waste management by Ajay Kalamdad sir. And this time I am taking wastewater treatment and recycling by Manoj Tiwari sir from IIT Kanpur, associate professor. Okay, so sir will be teaching the lectures. And the lecture materials are uploaded already in the Swayam portal. I hope you all are clear about the Swayam portal, or just I will give you a glance. So you have to log in with the Swayam portal that will be directed to the NPTEL website. And here you can see about NPTEL and about the course. So this course is named as wastewater treatment and recycling, that was taken by Professor N.K. Tiwari from IIT. He was earlier in IIT Kharagpur School of Water Resources. Now he is associate professor in IIT Kanpur, and it was structured as a 12-week course. You have to have every week assignments. You can see the dashboard, and you can apply for the examination. The deadlines are given here. It's a 12-week course. It's for civil engineering and majorly for environmental and energy engineering students of UG and PG can apply for this. And the exam date is on 15th August. Sorry, 2nd November, and the exam registration will end in 15th August. If you need any certificate or credit transfer for your institute, you have to surely apply for the examination. You have to pay the examination fee. Otherwise, the course will be free. Okay. So, as it is a 12-week course, you can get a credit of 3 credits as per your institute norms. In NIT Trichy, we are having an equivalent of 3 credit courses. So, first week we are going to see an introduction about the wastewater, and second week we are going to see how much wastewater is generated and what are the characteristics of wastewater. And third week we are going to see the natural purification of this wastewater, and then what are the treatment philosophy in the fourth week, primary treatment process in the fifth week, secondary treatment process in the sixth week, and in the secondary treatment aerobic and anaerobic in the seventh week, and what are the sludge that is formed through the treatment process we are going to manage in the eighth week, and then tertiary or advanced treatment process in the ninth week, and how they are doing in current scenarios that we are going to see. 1 second, lots of people are joining. Yeah. So in the 11th week, we are going to see what wastewater recycle. After treatment, we are also going to see about the wastewater recycling. And 12th week, the technology selection for your current city or based on the scenarios, you can choose the decision making and all. We are going to see in the 12th week. Okay. So the reference books are also given here, and you are eligible for certification only if you write the examination, and the examination final examination score will be considered for 75% of the total score of 100, and 25% will be taken from your assignment scores. Okay, so every 12 week you have to give the assignment, and best out of this 12, 8 best scores will be taken. So you can also miss 4 courses, that is not a problem, but mandatorily you have to give.
Your voice is breaking.
Yeah, am I audible now? Is it fine now?
No, sir, you are not audible.
Hello, am I audible now?
Yes, sir, no issue.
Yeah, where I missed it? Can I repeat the certification criteria? Oh. Guys, am I audible now? Hello? Guys, am I audible now?
Yes, sir, yes.
Yes,
Yeah, thank you so much. Sorry for the inconvenience. It's a network glitch. Can I repeat the certification criteria now? Like out of 100%, 75% of your score will be taken from your exam scores, and 25% will be taken from your assignment score. So 12 week you have to write the assignment, and the best of 8 scores will be taken for your 25%. Okay. So in this mandatory you have to get 10 out of 25, and in the final exam out of 75 you have to minimum get 30 marks, then only it will be eligible for certification. Okay, this is the basic about NPTEL and about this course. So you can see the dashboard here. If you register for the course, you will be redirected to this page, and here you can see week 0 assignment will not be taken for your assignment score. Okay, so week 1 we have the NPTEL team has uploaded 5 lectures and lecture material and the quiz. So quiz you have to clear by Wednesday. Every Wednesday you have to give the that's the deadline for assignment. So this week Wednesday is the deadline for assignment 1. I think they may extend only for first week, maybe up to next week. So every Wednesday it will be the assignment deadline. Okay, so don't forget to give before Wednesday. And then week 2 also it's open now. Today they have uploaded the week 2 lectures. So my 2-hour session will go. Actually, I am a PMR scholar and I am taking this course, problem solving session. Parallelly, 2 more PMR scholars are also allotted for the same course. One scholar is taking on Saturday, and Tuesday 6 to 8 also another scholar is taking. My session will be every Monday 6 to 8 p.m. So if you want to attend my class, you can see me in Monday 6 to 8 live session. Or else if you miss the course, I am already recording the course and I will upload the same video in the YouTube, and the link will be shared in here. You will get a new tab called PMR of problem solving session below that week 2. So there if you click, you will get the YouTube video link, and all the lecture material what I am taking and the problem solving materials I will upload in a Google Drive. That link will also be shared with this tab. Okay, so that we can see from next week onwards. So if you miss the live class, you can see my videos there. I think my 2-hour session will go like first 1 hour I will teach the same lecture material what sir has taught in the videos, and second 1 hour I am going to solve the old assignment problems that was uploaded in 21, 22 and 20. So that I am going to discuss here. Okay, and I will help you to solve the problems. So any doubt if you have, you can stop me in between the lecture, or you can ask anytime. You can unmute or you can post it in the chat box. I will ready to answer. So anytime you can contact me through mail or through this course portal also. Here you have a tab called Q&A. So if you go to Q&A, you will be directed to Google Groups. So there also you can give some of the queries. I will answer every 2 days once. So that also you can use the platform. Okay, so that's all about NPTEL and this course. So if you have any doubt about the course overview, you can ask, or else I will start today's session, first week session. Okay, so if you want certificate, please register for the course. If you want to attend the course just so you don't need to pay, you can attend the course. Okay, so that's the broad overview. So let me go with the lecture material. Yeah, so can I start now? Anyone have any question, you can post it in the chat box in between. I am ready to answer. Yeah, great. Okay, so this week we are going to see a broad introduction about wastewater treatment and recycling. If somebody have attended already watched lecture video, so you can also just I am giving a glimpse. So it will be in a 1 hour only. So I will just rush through the lecture material. That will give you the overall view of this lecture material, and you can answer the questions. So I'm giving them important points in this. Okay, so the title is wastewater treatment and recycling. So here we are going to see what is wastewater treatment, what is wastewater recycling, why we need to think about this wastewater treatment, and why we need to think about wastewater recycling. That's what the content for this week. Okay, so hope you all know about water and wastewater. So water that is used, that is called wastewater. So that's the dictionary meaning, and also given in most of the Oxford dictionaries. So you can see water that is used and not having any value, that is called wastewater. But if you think about the wastewater, its maximum content will be 99% water only. Yeah, if you see pollutants such as nutrients or organic matter or microbial contaminant, because the water that is flushed from the toilets will have some microbes or contaminants. The water that is flushed out of agricultural field may have some nutrients because we are adding fertilizers and all. The water that is coming out of kitchen or laundry, that may have some organic matter because we are using food waste or something in the water. So all these are called pollutants. But if you measure the pollutant in the wastewater, it will constitute not even equivalent to 1%. So more than 99% will be water. So you can think wastewater as a resource, or you can think wastewater as a burden. So you have to remove the 1% pollutant and you have to use the 99% water. That's why the course title was wastewater treatment and wastewater recycling. You got it? That's the broad overview of this title, wastewater treatment and recycling. So what is wastewater treatment? The process to remove the pollutant or the contaminant in the wastewater, that is called wastewater treatment. Then what is called wastewater recycling? After treatment, what can we do with this 99% recovered water? Where can we use? Because not all 100% pollutants are removed from the wastewater, so there may be some pollutant in that, so we can't use for drinking or any other purposes. But there is specific purpose so that what the treated wastewater can be used, that is called wastewater recycling. You got the idea? So that's the title. Okay, so you have to think the wastewater as a burden or you have to think as a resource. So that's what you will learn from this course. So this requires you need to have a engineering technology to transfer wastewater into a treated wastewater, and your social acceptance you have to develop, and you have to give a public awareness so that the people can use the treated wastewater, because people may think wastewater as a wastewater only. So you have to tell them the technology is suitable to remove the maximum contaminant, and this can be used for this purposes. So that social acceptability is required, and financial and economic viability is also a major part, because we need money to treat the wastewater. And environmental sustainability, the technology should not be more costly and more environmental footprint. It should have a low cost technology, and you need to have a low footprint environmental sustainable technology to remove, because you can't evaporate all the water so that you will treat all the water. So that's not economic friendly and environment friendly. So that also you have to think. Less energy consumption, less money consumption, that kind of technology you have to choose. That's what we are going to see in the 12th week decision making. Okay, so what's the objective of this course? You have to understand wastewater as a resource. It should not be a burden, it should be a resource. And you have to recognize the available technologies. We are going to teach what are the available technologies to treat the wastewater. And you have to learn about the issues and challenges in the wastewater treatment, so that you can overcome those issues, and you can also propose some more technologies. Okay, and also you have to gain some technology suitable for wastewater recycling. Got it? Yeah. So that's what this 12-week course content that I have already explained to you. Okay, here we are going to think uh, like what the wastewater will contain. So it is a liquid waste that is coming from any process. So process mean in the sense industry process or a household process or any commercial areas or any institutions like schools, colleges or anything that may produce whatever the sector that uses water, that will generate wastewater. You got it? So I am a student in a college, so I will use water. So surely this institute will also produce wastewater. If you are in a market that is a commercial area that requires water, so that will also have wastewater. If you are in a running industry, no industry will survive without water. Any one process will always have water consumption, or the people who are working there will require water. So surely they will produce wastewater. So that is a liquid waste. That is a byproduct of many uses of water. So we can divide the uses as household uses, industrial, commercial, agricultural, livestock uses. We can divide. Okay. So what are the sources the wastewater comes from? First is agriculture. That's a huge quantity of water that is coming from, because we need large quantity to irrigate the agricultural field. So the excess irrigated water will come as runoff. Runoff, you know, right? Whenever the rain comes, the excess water above the drains will flow as, so the excess water will flow as runoff. So that the same water that is coming out from the agricultural field are called irrigation water runoff. So that contains lots of fertilizers or any pollutant that is already present in the agricultural field. And domestic water, that is what we are consuming, the municipals, the households that is consuming. So household in the sense, household plus commercial will combinedly call us municipal or domestic wastewater. And then industrial wastewater, any industries you can think like a dairy industry or a brewery, beverage industry, fertilizer industry, that will consume water and that will also produce wastewater. This is the three major sector: agricultural, domestic and industrial. Another fourth sector that will not come under wastewater, but that is also one of the category of wastewater, that is storm water, that is the rainwater runoff. But that will be having only sediments, and that will not be considered as wastewater. That is considered as a water resource. We are having rainwater harvesting system. We can directly use the water. No need of treatment. Yeah. So if you're coming to the types, four major classification, and the last one will be runoff. So that will not be a wastewater. Other three will be domestic wastewater, industrial wastewater, and agricultural wastewater. Domestic, the other names are called municipal or sewage, we will say. So whatever the sewers we are having in front of our homes or institutes, the sewer lines in the roads, that are called domestic wastewater sewers only. Industry we will call as effluents. Agriculture we will call as runoff. Okay. So this is the major thing, and we have a color code for each of this. So agriculture will have lots of organic load and nutrients coming out of this. So that is called a green color. Storm runoff will be majorly pure water. So that is called a light blue color code. And households will have lots of color codes that we are going to see here. So if you think less pollutant to more pollutant, the color will change from light gray, heavy gray, brown water, and yellow water. So in the toilet, if you see, urines are called as yellow water. Sorry, yellow water, and feces and the toilet flush water will be combinedly called as brown water. So this brown plus yellow will give you the black water. You got it? So this is totally the black water that is coming out of the toilet. That will mostly have organic pollutant in it. Okay. The other household contents like shower and bathroom taps. So that will not have much pollutant. Only the soap that will be washed with lots of water. So that is a light gray water. Other than that, dishwasher, kitchen taps that will have some more organics, and then washing machine waste water, that is the flush water, that will have some organics. So that is called heavy gray water. So if you think about low gray water, sorry, light gray water, heavy gray water, and then brown water, the brown plus yellow will commonly call as black water. So this light plus heavy will give you the total gray water. That's a less polluted load. Okay, so this is the overview of color coding of our wastewater system. Industry, if you see, all industry will use water in at least one process, so they will produce wastewater. And agricultural, another third sector. First sector is domestic, second sector is industry, third sector is agricultural. Agricultural water that is coming out of the agricultural field, that is the runoff, that contains flush water from all the field that uses fertilizers, pesticides, fungicides, everything, whatever they are using, that will come out. So most of these pesticides will contain nutrients, or they will add some NPK like potash or phosphorus in the field, that will also come along with the water. So that is having mostly nutrients, and the sand particles, that is the sediments, or agrochemicals like fertilizers and pesticides. You got it? So these are all the major pollutant we can expect from agricultural runoff. Yeah. So what is a pollutant? How can we classify the pollutant? So pollutants are the unwanted substance that is present in your water. Then the water will become wastewater. So where it is present, how much it is present, it is an anthropogenic or natural contaminant, and what is the health effect if it is present in the wastewater? That is what we are going to see. We are going to classify the pollutant. So we have two classifications. One is pollutant, another one is contaminant. So contaminant is one part of pollution that will be if you have a eye drop or any medicine, if you touch the knob, then it will become contaminated, so you can't use that, but it will not have much impact on the solution, right? So that is called a contaminant. So if you have any small sand particle, or any, if you think a glass of water having a drop of oil, it is a contaminated water, but it is not health, it's not having any health hazards. You can even drink the water, right? So there is a difference between pollutant and contaminant. A glass of water with a drop of oil is contaminated water, but it is fit for drinking, so it's not a polluted water. But if you have a glass of water contaminated with a drop of any sewage, then it is unfit for drinking or any human consumption, then that is called a polluted water. So polluted is a poisonous, contaminated is any small foreign substances. So pollutants are always create harmful effects. Contaminants do not have any always create harmful effects. Okay, so the pollutants are contaminants that have exceeded the concentration. So that's the difference between pollution and contaminants. So another classification for wastewater is wastewater sources are point source and non-point source. If you know where the wastewater is coming from, then it is a point source. If you don't know where the wastewater is coming from, then it is called a non-point source. You understand? So I have a different sewer lines that is discharging wastewater into my lake or a pond, then I know which pipe is discharging. So that is a point source. So identifiable source of pollution, like any sewer system, oil refineries, animal feeding operation, ship, because I know which ship is discharging, and septic tanks, landfills. So I can easily identify. What are the sources that is not identifiable? Like any excess fertilizer coming out of the agricultural field. I can't find which field is producing, contributing to my wastewater. And like bacteria and nutrients in the livestock, or any leak in the sewer lines, we can't find where it is, right? So that are all non-point source of pollutants. Okay, so if you see the difference between the point source and non-point source, you can control the point source because you know where it is coming from. But non-point source is diffuse source. We can't. It is coming from many diffuse sources. You can't control it easily. So you have a easy control over it. Here it's a cumulative effect. It can be easily monitored point sources, but non-point sources are difficult to monitor. Okay, and you can regulate some standards for this point source. If any industry is polluting, you can find the industry. You can have a regulation for that. But if you have a non-point source, you can't find which industry is giving, so you can't give a regulation for that. Okay, and you can't find the dispersion rates. If it is a point source, you know how it is going to disperse. I am discharging my wastewater here, so I know how much it is going to come here. I can model it through modeling of wastewater. But if it is a non-point source, I don't know where it is coming from. I can't model how much it is going to come here. So that is the problem with the dispersion. Okay, dispersion is how much it is going to reduce or increase along the course of water. Yeah. So if you see the diagram, you can see a cropland is a non-point source. We don't know which agricultural field is contributing. Like that, if you see the wastewater treatment plant, I know it is going to discharge here. You can easily find with the color change itself. So that's a point source. And a factory, that is a point source. Yeah.
Hello.
Yeah, please, sir.
Sir, the non-point source, how can we find the capacity of STP point?
Uh,
Can we find out that is there any method to find out that what amount of capacity is required by non-point sources?
No, non-point source of wastewater, or like you are not talking about the STPs, but that is collecting the wastewater. We are talking about the STPs effluent that is discharged in the river or lake.
Like non-point sources and drains are this open drains.
Open drains. Yeah.
How can we define that? That would be non-point sources. It would be a non-source.
No. From the STP, the disposal point will be a single pipeline.
Yeah. But the sewer which is now running in an open drain, that would be a non-point source.
Yeah, that is a non-point source. The drain that is discharging into the pond, that is a non-point source. But the
Yes.
treated effluent coming from the STP is a point source.
Yes. So how would we decide the capacity of STP for a drain, sir, an open drain?
No, there is another category. So the drain is designed for collecting storm water or only for sewage. If it is a sewage, we know how much we are collecting based on the population of the city. If it is a drain for the storm water, we can also estimate the quantity based on the rainfall, but it is difficult to treat. That's why we are having two sewer lines, one for drain that is collecting the rainwater, and one for sewage that is going to discharge in the STPs. Yeah, so we are treating only the sewage that is collected in the drains. We are not treating the storm water that is collected. Yeah, this is the difference. So drain will be a common term, but sewer lines are different. Drains and sewer lines. Yeah, sir. Thank you for the question. And so you can see the examples of point source. You can identify with the color code itself. I am saying now. So a industry is discharging here. So I can find the industry because you are discharging. And here I can find which pipe is discharging what nutrient, or I can easily collect here and measure. You are exceeding my standard. You should not discharge. So that is the standard for each industry. In Tamil Nadu, if you see, we are adopting zero liquid discharge. No industry should discharge any liquid out of their industry. So if you are using 100 liter per day, you should not have even 1 ml out of the industry. You have to treat on your own. You have to treat only the prescribed standard or zero liquid discharge. You understood? So they have to reuse on their own. We are only supplying the fresh water. We are not taking out the effluent to treat. So all the industries are now with ZLD in Tamil Nadu, and many states are following ZLD system, the zero liquid discharge. Okay, we are not allowing them to discharge even 1 ml out of the industry. So that kind of system also there. And if you see non-point source, as Sas mentioned, this is our drains, rainwater that is running out of the drains. So that is considered as non-point source. And agricultural runoff is also considered as a non-point source. If you put together all the non-point source and collecting in a drain and discharging that drain into a single point, then we can convert the non-point source into point source. So that is one criteria you can follow. You understood? So that is the thing here, difference between point source and a non-point source. So why we need to manage this wastewater and why we need to treat the wastewater? Because if you discharge directly the sewage or the wastewater into the pond or a river or any water system, so it will have a severe consequence. First is human health will get affected. Second one is environment will get affected. Third one is economy will get affected. These are the three major reasons we have to treat our wastewater. We have to manage our wastewater. First, health effects. What it will cause? Because if you directly discharge your wastewater, water related diseases that may origin like cholera, dengue, diarrhea, these are all waterborne diseases. So that will again increase in your area. So you have to treat. In 2012, if you see the statistics, around 8.5 lakh death was happened in middle and low income countries due to contaminated drinking water, because we are getting drinking water from river sources. Okay, so if you pollute the river, then your drinking water is contaminated. So you will get waterborne diseases. So if you see the risk, unimproved sanitation will have high risk. So if you have a community sanitation or receiver connection, you will have a low risk. Okay, so that is the risk category. You can categorize the wastewater treatment management systems, and this is about health. What about the environment? So if you discharge untreated wastewater, the receiving body, that is a river or any lake, that will have a huge amount of water resources that is already contaminated. So if you think about the statistics in India, increasing in most rivers in India, if you see Ganga, Yamuna, most of our perennial rivers are already polluted with industrial discharges. So that we have to think about. We are losing our water resources for our future, and it has a direct impact on the ecosystem, because not only humans, whole ecosystem is based on the water resources that will get affected. Okay, and eutrophication, and we may be going to see in the upcoming weeks. So I'll just give you a glimpse what is eutrophication. So that is a process whenever you are discharging nutrient into the water bodies, like you have a soap or you have a soap will contain phosphorus, and agricultural runoff will have nitrogen and potash. So if you discharge all this NPK into your water system or a pond, so the pond, whatever the like algae in your water bodies will eat this nutrients and it will grow. So you can see a green color pond. So that's called eutrophication. What is the problem with that? If more algae will form, that will have a layer over the surface of the pond. So the fishes in the pond will not get any dissolved oxygen to breathe, because all the aquatic organism will require oxygen similar to our human beings, so that it can live. So the dissolved oxygen will reduce, all the oxygen will be consumed by the algae, it will grow, and the fishes will die and it will float on the water bodies. That this type of things are called eutrophication. I can show you the images for eutrophication. If you uh, see some of the figures, you can understand. Yeah, this is the kind of
How can we treat such a concept?
so the only thing is you can't treat, you have to stop the discharge.
And naturally, it has to regain itself.
Yeah, there is a process called a natural regeneration of water bodies, but that will take time. If it is a continuous flow system like a river, that can easily replenish. But these are all stagnant water bodies like a pond or a lake, so that will take a lot of time to replenish.
So, any process to rectify these things?
So if you have a collection system, you can, if you are having a sewage that is contain nitrogen, phosphorus, potash, you can treat. But if you have a pond that is containing wastewater, I think you have to first cut off the source, and you have to think about I think it will automatically replenish in a year's rainfall. It will easily replenish. If you don't have source, algae will die because it's not having any nutrient.
So,
So no growth of algae, easily it will die. So you can easily get the oxygen. That's it. So the main problem is you should not discharge the wastewater into the source. You have to treat the wastewater. Yeah. So the third one is economic. First one we have discussed about the health impact. Second one is about the ecosystem. Third one is about the economic impact. So all the tourism or major things of our economy is based on the water bodies. We have fisheries, we have tourism, we have a transport system based on ships and all. So all this will get affected if the water is polluted. So that is a obstacle to the economic development. Externality cost. It's not called it's not have a direct impact. It has an indirect effect on the economy of the country. That is called externalities. Okay, so that is also have a major, and all the industries are based on the water source. If the water source is polluted, no industries can run, or the products quality will affect. So like agriculture, industry, productions, fisheries, aquaculture, navigation, tourism, everything will get affected. So the economy of the country will get down. So that's the economic impact. So all these three will be the major burden to the country based on the poor waste management systems. So that we have to treat the wastewater, because we need a fresh water. We need to improve the quality of the wastewater, so that we need to have a proper treatment system to reduce the load, so that we are studying this wastewater treatment course. Okay, so what is the effective waste management cycle? To be the waste management system should be effective, we need to first prevent or reduce the pollution. As I mentioned, you have to first stop the source, so that you can think about the treatment. First prevention or reduction of the pollution at the source. If you are reducing less pollution, then you will causing less pollution, then you will not no need to treat that much. Okay. Second one is whatever the already polluted thing you have to treat. So removal of contaminant. Third one is reuse of wastewater. After treatment, what can we do? Then the treated some byproducts will be there. So sludge or something will be there, nutrient extraction, whatever the extracted thing, that also we need to use. So the 99% reuse treated water need to be used. That 1% pollutant also need to be used as a byproduct. Okay, these are the whole effective management cycle. So you have to first stop the source. You have to treat the wastewater. You have to reuse the 99% water. You have to also think about the recovery of 1% pollutant, because that is also one nutrient that is embedded in the water, that also we can use again, right? If you extract as a again you have to use as a byproduct in any industries. Yeah. So if you think about the recycling perspective, wastewater is contains a water source, it's a nutrient source, it's a energy content, because you can generate energy from wastewater by anaerobic digestion. You can get methane, you can generate energy, that is biogas or incineration you can do. Organic matters are there. So if you if you discharge the wastewater into the wetlands, so you know about wetlands, I guess. Wetlands are the natural ecosystem formation that can treat the wastewater. Simply you can discharge the wastewater into the wetlands, so that carbon and nitrogen will be taken care by the plants that is present in the wetlands. It can treat the water, and it can supply the or discharge the pure water into the water bodies. So lots of wetlands are there. There is a Wetland Conservation Act in India. There is a World Wetland Day, and there are some Ramsar sites are there in India. So recently, in 6 months back, also they have introduced two more wetlands are considered as Ramsar sites in Tamil Nadu. You can think about that Ramsar sites in Google. You will get lots of information about that. Um, So you can see lots of Ramsar convention, and you can see how many wetlands are there in India and locations. Okay, so that will give you a broad idea on how to. These are all wetlands. So you can see the wastewater. If you discharge, the root and the plants can absorb the carbon and nitrogen present in the wastewater, and it will give you the fresh water. Yeah. So that is about organic matter extraction, and other byproducts also we can get. So lots of resources you can see in the wastewater. Water as a resources, nutrient resources, energy we can get, organic matter we can get. Others like byproducts like protein feed to the livestock, like aquaculture we are doing with the wastewater. So that are all as a recycling perspective, you can think about the wastewater management. Okay. So global scenario, if you think how much they are doing as of now in low income countries, 92% are uh, like untreated wastewater in 2015, and they have a target for 2030 as 46% to be reduced. So 92 to 46%, that's the reduction target they have, low income countries. And India is a low middle income country, and we are in as per 2015 data, untreated wastewater we are having 72%, because if you collect 100% wastewater, only like 72 means like 28% we are discharging without only 28% we are treating. Other 72% are untreated and discharged. So by 2030 we have to get the target of 36%. Okay. So if you say high income countries, they have most a good treatment facility. 70% they are treating, only 30% is untreated. This is a global scenario of you can see the UNES document of UNESCO, that is the report. If you see the Indian scenario, we have a different class of cities: class 1 tier city, tier 2 city, tier 3 cities, like that. So tier 1 cities are discharging 68% of untreated water, and only the remaining is treated. And class 2 cities, 92% are untreated, only 8% is treated. So if you think about the whole, you have as India, 70% is untreated, only 30% is treated. That is matching with the low and middle income countries. So that 70% we have to treat. So that is the target for 2030. That's a global target. Okay. So if you again split the like category wise, in urban sanitation situations in India, toilet coverage, we have the lowest of 16% in some countries, sorry, some cities, and we have 100% in some cities. And sewer networks, some cities have 100%, some cities have even 4%. Think about the lowest city that is having only 4% of sewer connections. So how can we collect that waste and treat that waste? So that is the aim we have to have. So Swachh Bharat Mission Gramin have a that was launched in 2014. That is the Swachh Bharat Mission. You all know about that. Open free, sorry, like free, sorry, open defecation free. That is the motive of this Swachh Bharat Mission that was started, and it has all the sanitation component in it. It was launched in 2014 on the 100th anniversary of Mahatma Gandhi, and then it was having a lot of targets. So earlier it was the first target is to increase the sanitation coverage from 39% to 76% in 2018. So that was achieved. So if you have a overall, you will find 76. But if you see the some of the cities having even lowest percentage, that also we have to have a benchmark of 100% to 80%. Okay. Yeah. So what is the issues and challenges we are facing in treating the wastewater? All the, as we know, all cities are moving towards urbanization and industrialization. So all the pollutants are increasing. Water demand is the major thing. So how to have a industry process that will consume low water consumption? That is the first thing you have to think, so that you will produce less wastewater. So that is the first thing you have to think about. If you have more consumption, then how you treat? So that is a major challenge, because we have a system, STP or whatever the industry treatment plant, that have to handle. If you say example, if it can handle 100 kiloliters per day, then if you are discharging 200 kiloliter, that demand, that is the major thing. Demand you can't sustain. Then second point is emerging contaminant. We have designed the STP to handle only the organic pollutant or nutrients, but nowadays we are discharging lots of emerging contaminants because people are taking lots of tablets. So that will come out as a pharma affiliate, contaminant in your urine or feces. So that will be a pharma contaminated wastewater. People are using lots of cosmetics, lots of body care products. So that are all emerging contaminants. Our STPs are not designed to treat all these emerging contaminants. So people are working on personal care products, pharma, wastewater treatment systems nowadays. In our research team also, the people are working on treating this type of emerging contaminant. Even microplastic is an emerging contaminant, because if you see, think about a nail polish, every day they are removing again with the nail polish remover. Everything is an emerging contaminant. It has a microplastic in it. So that is not that is the issue in wastewater treatment. Third issue is pollution of freshwater resources. So we are disposing the treated wastewater in the freshwater. Again, if you are not treating to the standards, your freshwater system is damaging. So these are the major three issues: how to manage the demand, how to treat this emerging contaminant, how to discharge the treated effluent. These three things we have to think, and we have to study this course. Okay. So wastewater recycling is becoming unavoidable. So because we have to dispose somewhere. Yeah. Another challenge is, can we collect the wastewater centralized and treat, or that we can have a decentralized wastewater management system? What is centralized? You have to collect from all the households and you can treat in a single wastewater treatment plant, or you can design wastewater treatment plant in each part of the city. So what is the problem here and what is the problem here? Here, the wastewater have to transport through a large distance, because if you generate a wastewater here, that need to transfer to a large distance and it need to reach the wastewater treatment plant. So that will add transport cost, and there may be some contamination during this transport. But you need to have only one STP, so construction cost is very less. But if you think here, there is no need of lots of transport because you are treating here itself. What are the wastewater generators? So less transport cost, less level of contamination, but you need to have a lots of STPs to be constructed. So that is not practically possible. So you need to think about which is optimum for which city. That is the optimum design you need to think about. Okay. Yeah. So other major challenges are you don't have the people don't have a lot awareness, and we don't have a finance political will. The government have to support for this type of system. If you have a optimum design, the government will support. And the footprint, the system should not consume more energy. That will again have a carbon footprint, energy consumption, trained and skilled manpower. You have to have a simple design that can be operated by any people. Like a rainwater harvesting system is a simple design. Even any household people can do lots of like Kerala now they are having biogas system or anaerobic digester in their backyards for their food waste or any organic waste. So that is easily they can do. Even household people can do. So that type of easy things we need to have. And development of adaptable technologies and quality control of the treated wastewater is the requirement of the hour. Okay, so this is all about the introduction on wastewater and why we need to study this course. So I hope all of you understand about this week's lecture. If you have any doubt, you can unmute and you can ask, or else we can move to the problem solving section. Mostly this will be a theoretical course, I guess. Some problems will come that we can solve in this problem solving session. If you don't have any question, I will move on to the old assignment problems. I'll wait for a minute. I hope it is clear to everyone. If you want to reduce my speed or increase anything, you can, or any, you have to change any content, or you can say, I can change in the next week.
Can you please explain eutrophication again?
Yeah, sure. So, let me take the pen. So, if you have a pond or a lake system and you are discharging your wastewater in this, and the wastewater may contain nitrogen or potassium, sorry, phosphorus or potassium in it, that are all nutrients. Majorly, it will be our agricultural runoff will have this kind of nutrients in it. That's the wastewater. So, the water may contain fishes or aquatic life in it. So, this fish or aquatic life requires dissolved oxygen in the water. So all the atmospheric oxygen will also be dissolved in the water. Sorry, sir. Yeah. So all the oxygen will, all water body or any aquatic system will have its own dissolved oxygen system based on its temperature. So every system will have a dissolved oxygen in it. So all the fish or any aquatic organism will rely on this dissolved oxygen to breathe. Whenever this nutrients comes in, all the algae will because this aquatic organism will not require nutrients, but this algae requires nutrients. So whenever nutrient comes, this algae will start growing, and it will take NPK as a food, and it will take dissolved oxygen as a respiratory source. So all the DO will be consumed by this algae, and it will form a thick green layer above it, and no sunlight can pass through the water bodies. Sunlight is also required for the aquatic organism. So whenever there is a sunlight, whenever there is a nutrient, whenever there is a DO, all will favor the growth of algae. So whenever the algae grows, so the less dissolved oxygen for the aquatic organism to live, so it will die and it will float on the river, water bodies. So that is the eutrophication process. Sorry, eutrophication scenario. It's not a, it's a whole thing. It will cause a damage to the aquatic organisms. So hope it is clear, sir.
Yes, thank you.
Yeah. So you can see some of the figures here. So this is the kind of
The NPK is basically the function which the topsoil also has, right? The fertile soil, the topsoil, the upper 20 centimeter layer, also consists of these NPK values, right?
The soil you are talking about.
Yeah. I'm
Yeah,
talking
we
about
are,
soil.
we are adding nitrogen and potassium as a salt to the agricultural field for the growth of the plant. But whenever the fertilizers are in excess, whenever rain comes, this excess fertilizers are taken by this runoff and it will reach the water bodies. So, major thing we have to follow is optimum use of fertilizer in the agricultural field. We should not use excess fertilizer in the agricultural field. Then there won't be any nutrient in the runoff. That's why now people are having easily dissolving fertilizers that can be taken by the plants. So smaller amount at the required plant root they are adding. That's a recent technology they are doing nowadays. Maybe those who are from farming field they can easily answer this type of questions. Yeah.
Use nutrification, we have to use optimally. We have to use optimally the fertilizers and
That,
herbicide, the
uh,
fungicide.
that is that is one that is one source. Another thing is if you are washing, many people are washing their clothes in the lake or pond. So our what we say like detergents may have lots of nutrients. Yeah, this is also a nutrient source to this type of algae. So not only the agricultural field, we have lots of sources for the nutrients to enter into the water bodies. So all this we have to stop.
Thank you.
Yeah. Yes. Any more questions?
So,
Yeah, ma'am.
for centralized water treatment plants and decentralized, which one is better?
That's what I said. It's based on the city what you are doing planning. If you don't have a finance, I mean, finance is based on again two characteristics. One is STP construction, another one is pipeline construction. So, which is optimum in your area based on the quantity of water that is you are generating? You can think about this. I think decentralizer is good for industries. Centralizer is good for domestic. That's what I can as an overview I can say, but it will not also suitable for all the cities. But industries you can think because smaller industry can have a or combined ETPs we are having. STP is sewage treatment plant for municipal solid waste, sorry, municipal wastewater. ETPs are effluent treatment plant for industries. So if you have a cluster of textile industries, you can collect all the water from textile industry and you can give into the textile effluent treatment plant. And in the same sector, industrial sector, if you have lots of what we say oil refinery industries, you can collect from that and you can have a separate ETP for that. So that kind of clustering of industry can be possible in decentralized management system. But municipal wastewater you can collect as a single because mostly it will be a similar characteristics, mostly organics. Okay, so that you can think about centralized. So we need a optimum design based on the quantity, based on the type of pollutant, based on the source.
Okay, so thanks.
Yeah.
Sir, yesterday we had a debate on type of STPs to be used or type of saver.
Okay.
So we were not actually through with that discussion. So you can throw a light on that also, sir, like which type of STP to be used on where? What is NBPR?
Okay, we're talking about it's not a type of STP, we're talking about the technologies.
Technology, yes, sir. Type of technology. Sir, which one suitable for which plant and how to decide on that?
I think this we can discuss in the 12th week. That is the decision making.
Yeah.
So, as far as I know, I can say SBR is suitable for low quantity of wastewater. MBBRs are good for wastewater having mostly organics, and then because membranes are not suitable everywhere, and SBR will have less area consumption because mostly STPs will have requires lots of area to construct, but SBR requires only a small system because it's a batch reactor, not a continuous and but most of the STPs still we are focusing on what we say ASP like activated sludge process. So that's consuming lots of primary settling tank, aerated tank, and secondary settling tank. This is the process flow we are having in most of the STPs. Industries are following this type of new technologies like SBR and EBBR. We have also last month we have visited Tamil Nadu Paper Limited, that is TNPL. So here we had seen MBBR technology there. So each industry can design on their own. SBR we had seen in one of the textile industry in Tirupur, like that. You can think about the pollutant and you can design the technology.
So for municipal waste, how would you suggest, sir?
Municipal, as of now, practically feasible is ASP. ASB is already there in most of the systems. I think now we are focusing, our research are focusing on tertiary treatment. Whatever the treated municipal solid, I'm sorry about the solid waste. I am working on solid waste. I am repeatedly saying solid waste. The treated wastewater, what are the emerging pollutant that is present after treatment? How to treat that? For that, we are thinking about the system. So actual treatment system will be ASP. That is the biological treatment system that we are following. Okay, so tertiary you can think about. So this whatever you are talking about SBR, MBBR, MBR, everything is a tertiary treatment. So treated wastewater can be the input for this type of technologies. You can't use that as a initial treatment facility because your membrane will fail if you have lots of this type of organic load. Every day you can't change the membrane, right? So that and all will not work for primary treatment. Primary treatment should be with this type of things, secondary and all. Tertiary will be kind of advanced technologies.
Oh, so there should be a primary treatment also for a.
Yeah, that is mandatory. Hope you got this. Yeah.
Yes, I get it. Thank you.
Mm.
When we talk about STP versus ETP, we usually say that the reuse of STP can be used in horticulture purpose or toilet flushing. Or
So STP is sewage treatment plant. Sewage is
right.
yeah.
So what I am talking about is the reuse of the treated water, the
Yeah.
water which is used for flushing purpose, right? But in case of TPs, they say
Sir, your voice is not clear. Only to me or to everyone? Sir, I couldn't get you.
No, not clear.
Yeah, sir, please. Can you repeat, please?
yeah, sure. I'm audible now.
Yeah, please.
Okay. I was saying that the output of STP can be used for horticulture purpose or toilet flushing, right? But some ETPs, they will use soaps and detergents for treating the soaps and detergent and
I got your question. Maybe you are talking about how can we reuse the treated effluent from the industries. Yeah. So, as far as Tamil Nadu is concerned, we have a zero liquid discharge. So, all the industry after any treatment technology, we have a multiple effect evaporators. So, that will contains evaporators or a multiple effect evaporator. I can think maybe we have in this course, I guess. So, that will evaporate the treated effluent so that we can get only the salt or the residue. All the water will be evaporated. So, that's the technology we are using so that we cannot rely on so that also have energy production because the steam we are producing the steam can be used for energy production and the recovered salt or because if you think about any industry that will have only one pollutant in that, not like sewage. So industries will have only one type of pollutant, so that can be easily recovered and they can use in their own system. So I think as many industries are using multiple effect evaporators, MFEs, that you can think about. So I think they are not discharging anywhere or they are not reusing also. And if you think about dye industries or textile industries, how they are reusing, like first dyeing. Earlier they have this type of one batch will come in dye and then the product will go out and this water will be flushed out. Now what they are doing is this can be used as a secondary water and first dyeing and then for this also used for second dyeing and like third batch, fourth batch, like that they are using and then discharging. So whatever the polluted water, that also they are considering as the product. So like that you can reuse. Any like a mining industry or metal smelting industry, they have only one type of metal that can be recovered and used for their product. Yeah.
Okay, thanks.
That cannot be reused until it is not organic. You can't discharge anywhere. So that's the broad idea we can take.
Okay, thank you.
Yeah. So any more questions? Okay. Let me go with this um, problems. That is the basic problems I am going to discuss. That is the old assignment problem. Don't forget to give this week assignment before Wednesday. Every week Wednesday is the deadline. And you can post the answer in the chat box. Now I will show the question. You can post the answer in the chat box. Within a minute, I will show the answer and I will explain. Okay. So first question is what is wastewater recycling? So treating wastewater for removal of contaminant, recovering beneficial nutrients or metal from wastewater, reclaiming water from wastewater and putting it to the beneficiary reuse, all the above. Can post ABCD in chat box. Like treating wastewater for removal of contaminant is not recycling, right? I'm not asking about wastewater treatment. I'm asking about wastewater recycling. Yeah. So how it will be? Recovering beneficial nutrients or metals, reclaiming water from wastewater and putting it in the beneficially reuse. Yeah, that may be correct, I guess. Right? How come it will be B? Because recovering beneficial nutrient is treatment technology only. It's not recycling. Recycling is we have to think about the 99% water, recovered water. So that is reclaiming water from wastewater. That is the 99% of water. Let me take the pen. Reclaiming water, that is 99% water from the wastewater and putting it into the beneficiary reuse. So the wastewater contains 1% contaminant and 99% water. So this as a recovery of nutrient is called material recovery. This 99% into reuse is called recycling. Okay, the whole treatment process is called wastewater treatment. So option is C. Hope it is clear. So reclaiming wastewater from wastewater and putting it to the beneficiary reuse is called a wastewater recycling. Question may be tricky. Simply, if you read, you will get the answer. So that's the answer. Wastewater recycling is reusing treated water, reclaimed water for beneficiary purposes called wastewater recycling. Okay. I'll upload this material in. I will upload the recordings and also this material in Google Drive. That link will be provided by the NPTEL team in the portal, SWAYAM portal itself. So don't worry. You can no need to take screenshots and all. Yeah. So second question, wastewater generated from dash is not a component of grey water. So we have a color coding. So this is about domestic wastewater. Because agriculture is only green, because organics and nutrients. Grey water is for domestic. So domestic, we have kitchen, toilet, laundry and bathroom. Kitchen is a grey water only. Yes, toilet is not a grey water. Can we check the answer? Yes. So see here, toilet we have urine as a yellow water, feces and water. Feces is a brown water. If you merge yellow plus brown, that is a black water. That is a separate category. The less pollution water, that is called uh, gray water. So in that, shower and bathroom taps will be light gray. Other things which have high pollutant will be heavy gray water. Both heavy and light gray water is comparatively less pollutant than black water. Okay. Yes. So they are asking which is not a black gray water. So toilet is not a gray water. Yes. Identify the correct statement regarding the potential recovery from the wastewater. Through adequate treatment, usable water may be reclaimed from wastewater. Through adequate treatment, usable water may be reclaimed from wastewater. Is it correct or not? Then, second statement, wastewater can also be processed for recovery of energy as well as nutrients. Is the second statement also correct or not? Through adequate treatment, usable water may be reclaimed for wastewater. That is correct. Wastewater can also be processed for recovery of energy as well as nutrients. Why the second statement is not correct? Because wastewater is a source, right, for energy, for organic matter, for nutrients, for water. So I think C is correct. Yeah. So both statements are correct. Why you are thinking second statement is not correct? You think here. In recycling perspective, resources can be recovered. Water or nutrient or energy or organic matter or anything can be recovered as a byproduct. So second statement is correct. Wastewater can be processed to recover energy as well as nutrient. You got it? Yes. Okay. Please correct it. Okay. So fourth question. Hope you are coming with me, or can I go some more slow? Is it fine? Uh, We have 30 questions.
Yes.
Yeah. We have 30 questions in this. Yes. If you think about a non-point pollution source means, what is a non-point source? A source with negligible amount of pollution, a set of several small sources from many different locations, a source of pollution that was there in past but not more exist, a hidden source of pollution which cannot be identified. I think non-point source will have only one keyword, that is non-identifiable. Non-identifiable is the keyword. Option D may be correct. Right? Yeah. Oh, right. A set of several small sources from many locations, a hidden source of pollution which cannot be identified. Small source from many different locations. That is also correct. That cannot be a hidden source of pollution. Both seems correct. Let me check the key. Both seems correct because it has a keyword non-identifiable source. Also, it many diffuse sources from many different locations are also correct. Yeah, let me check the key. B also correct. D also correct. Yeah, we will work on the fifth question. I will answer this in the next week. Which of the following is an example of point source? They are asking about the example. Discharge of industrial effluent, discharge of discharge from STP, spill from oil refinery, all the above. Which of the following is an example of point source of pollution? Yeah. So STP you can find where it is coming from. Industry also you can find where it is coming from, and oil refinery spill also you can identify. So all the above is correct. Yes. So that is the point source: oil refinery, sewage treatment plant, and the STP. And one more is industry effluent. Yeah, manufacturing industries. Identify the non-point source of pollution among the following: urban and agricultural runoff, spill from oil refineries, discharge from ETPs and STPs, all the above. Wherever you can see the word runoff, you can say it is a non-point source, because until it is collected in a single drain and it is discharged into a single point, otherwise it is called a non-point source. Okay, so wherever runoff comes, it is a non-point source. So spill from oil refinery is a point source, ETP and STP discharges are point source. So answer is A. Yeah, so you can see here runoff, agricultural land, excess water.
I just want to confirm something.
Yeah.
The examination which will be held for this course will be objective type.
For final exam, okay.
Yes.
Yeah, as far as I know, most like it will be objective type. Some problems may have numerical type questions. We will see in the course of time if you find any problems like numerical problems, you have dash. That also you may have options. I don't think mostly you will get you have to answer the fill-ups. Mostly it will be the multiple choice only.
Okay. Okay. Thank you.
And you have to choose, like if it is a circle, it will be a single answer. If it is a square, you have to select multiple select answer. That you have to take care while in the examination. That also will come in NPTEL courses. Yeah.
No, that's not a worry for me. Actually,
Yeah.
I was confirming that whether it is objective type or
Yeah, it will be
subjective type.
objective. I have written, I think, more than 6 subjects. Mostly, it will be objectives only. And some courses it
Okay.
has
Okay.
2 or 3 numericals with the dash that you can take it. Yeah.
Okay. That's fine.
Okay.
Thank you.
Okay. So seventh question again. It's a correct statement regarding waterborne diseases with the poor wastewater management. Waterborne diseases are common in region with the poor wastewater management. That is correct or not? Then direct consumption of wastewater is the major reason for the spread of waterborne diseases in such areas. Mm, no, read the first line. The correct statement regarding the linkage of poor wastewater management. So, waterborne diseases are common in region with poor waste management is correct. Nobody is consuming wastewater, right? It is about consumption of treated, untreated wastewater. I mean, we not say untreated. It's like partially treated. Nobody will consume wastewater, right, directly. Or you can say consumption of water taken from the discharge point of wastewater. Like that, you can say the source may be a river or a lake, but that is contaminated with the wastewater. We are not directly consuming wastewater. So the second statement is wrong. So first, wait, I have chosen wrong. First is correct. First is correct. Second is wrong. Okay. Yeah, please correct it. So answer first is correct. Waterborne disease is a common region with the poor waste management, water management. Direct consumption of wastewater is region for it's not direct consumption. Nobody will consume directly, right? The wastewater. Yeah, but the statement is correct. If you consume directly, it will be a spread for waterborne disease, but nobody will consume. Yeah. Here, if you see, this is the health effects of the wastewater management. Um, the waterborne diseases eliminate if you treat or increase the sanitation, you will eliminate many diseases, waterborne diseases. If you see, wastewater related diseases remain widespread in region with the poor waste management system. Here you can see low or middle income countries caused by contaminated drinking water. It's not about direct consumption of wastewater, it's a contaminated drinking water. Yeah. So can you match the type of wastewater with the examples? Municipal, industrial and agricultural, farm runoff, wastewater from dairies, wastewater from schools and offices. So in municipal itself, we have two categories. One is household, another one is commercial or institutional. Commercial will be from marketplace, offices, institutions like schools, colleges. Household will be from kitchen, toilets, garden kind of things are household wastewaters. Okay. So if you match here, municipal will be C, 1C, industrial will be directly dairy, agricultural will be farm runoffs. So 3A, 2B, or yeah, C will be correct. Yes. So C is correct. Okay. So this is a type of wastewater. If you see domestic wastewater, industrial and agricultural runoff. Yeah. So ninth question, why grey water is relatively easier to treat compared to treating municipal sewage for reuse applications? Why grey water is relatively easier to treat? If you think about grey water and black water, can you say grey water is easier to collect and transport, or grey water is less in quantity, or grey water has less pollution load, or they are dedicated technologies for grey water systems? First, why it is called grey water and it is not a black water? Because it's having less organics. So the answer will be grey water has less pollution load. That's the reason why it can be. That's why most people are answer is C. Okay, grey water has less pollution load. That's why most people are reusing directly the grey water without any treatment. That also people are doing. Okay, but the black water or brown water cannot be reused without treatment. This can be reused without treatment because it's having less pollution. You can directly discharge in the gardens. This type of grey water. Some soap consuming plants are there. So that kind of plants you can adopt for this kind of detergent used in wastewaters. And light grey water is simply not having much load. That you can simply redirect to flushing. So that also you can do without much treatment. So the answer is it's having less pollution load. That's what I have mentioned here. Yeah. Often in centralized wastewater management system, what is about the centralized waste management? Several smaller size treatment facilities are needed. Long distance transport of wastewater is required. Quality control is difficult. All the above. So if you have large number of STPs, for small areas, then there is a difficulty in quality control because this may discharge in some quality, this may discharge in some quality. But if you have one STP, then you have only one effluent point. You can easily control the quality of the effluent. So quality control is easier in one STP, that is centralized. In decentralized, the quality control is difficult. Okay, so quality control is easier for centralized. So this option is wrong. Several small size treatment is required for decentralized, not for centralized. So this is also wrong. So option B is correct. In centralized, there is a long distance transport of wastewater is required because whenever there is a created, that need to travel to a long distance. So option B is correct. So that's what we have discussed. Transport cost is more, and there may be some contamination during the transportation. Yeah. 11th question. Wastewater is considered as a potential reuse resource because wastewater is considered as a potential resource because 99% of wastewater comprises water. The pollution content of the wastewater is very high. The wastewater processing to remove contaminants is fairly easy. Reclaimed wastewater is readily accepted by consumers for reuse. Why the wastewater is considered as a resource? Because it's containing 99% of water. Yeah, that is correct. That's what we had seen. This was 99%. Only the burden is 1%, not even 1%, less than 1% pollution. Which of the following is not a point source, non-point source? Sorry, which is not a non-point source? Sediment overflow from eroding stream banks, large sanitary landfills, nutrient from livestock and pet waste, irrigation runoff from agricultural. So runoff is surely a non-point source. So that is correct only. Then large sediments overflow from eroding stream banks. That is also we can't find where the sediments are coming from. So that is also a non-point source. Nutrient from livestock and pet waste. They are asking which is not a non-point source. Please read the question. Which is not a non-point source. Nutrient from livestock and pet waste. That is again like a livestock and all, those who are having cattle in their home, in their garden. So lots of cattle will be there in many gardens. So we don't know which cattle farm or a livestock is generating the nutrient. So that is also a non-point source. But a large sanitary landfill, we know that is the same landfill only the wastewater is coming. So it's a point source. So landfills is a point source. Okay. Okay. So which of the following is correct for domestic wastewater? So we have 4 categories: domestic, industrial, agricultural, and the fourth will be stormwater. First 3 will be considered as a wastewater. The third one will be directly the water resource. So the domestic wastewater contains gray plus black or gray plus brown or brown plus urine or heavy gray plus black. We have gray water, we have a yellow water plus brown water. Both the yellow plus brown will be combined as black, and this gray. So this gray plus black will be combined as domestic. So domestic will be gray plus black. A is correct. Yeah. So that's the total domestic. Okay, gray plus black. Which of the following is a component of black water? Black water contains yellow plus brown. So yellow will be urine, brown will be feces and flush water from the toilets. So all the above. No. Which is a component of not CD? Yeah. D is correct. Yes. So identify the correct statement concerning pollutants and contaminants. May or may not create harmful effects. Pollutants are foreign matter typically introduced from outside. Contaminant may or may not create harmful effects. Contaminants are either harmful or poisonous in nature. Actually, pollutants are either contaminant or poisonous. Contaminant may or may not create harmful effects. Contaminants are the foreign matters. So the answer is contaminant may or may not create harmful effects is correct. They are asking correct statement. This is pollutant are either harmful. So D is not correct. Let me go with the answer. C is correct. See here. Pollutants are poisonous. So this is wrong. Contaminants are foreign substances or impurities. So this is also wrong. Contaminant do not create any harmful effect. So this is correct. This is wrong. Pollutants are toxic. Okay. Pollutants create harmful effects. That's why I said if you please remember this, a glass of water contains a drop of oil. That is a contaminant because that is a foreign substance not required in water, which is not essential in the system. That is a contaminant. If you take a blood, if it is contaminated with a microbe, that is contaminant. But if it is causing effect, then it is a pollutant. Okay. So like that, water having a oil drop is a contaminant, but it is not having any health effect. But if it is having a sewage drop, then it is a pollutant. Okay. So moving to the 16th question, non-point source of pollution are usually difficult to monitor and control. Why? Many small diffuse sources from different locations require several spatial distribution monitoring stations. Difficult to determine the dispersion rate of the pollutant flow rate. All the above. Many diffuse sources are correct. Yeah. Difficult to determine the dispersion rate. Yeah, that is also correct. Because if you know the exact, it is a river. I have industry 1 here. I have industry 2 here. Discharging the effluent and the water flow is here. I can model easily. The concentration is C1, the concentration is T2. What is the concentration here? Can I take water from here? When the concentration will become negligible, where I can take the water? That I can easily model with the natural system modelings, water system modelings. If for a river, for a lake, for a pond, for a estuary, I can easily model based on the mathematical modeling or finite element analysis. But if it is a non-point source, I don't know where it is coming from. How can I model? How can I find the dispersion rate? So that is a difficult thing. And it requires a several spatial distribution monitoring system. I have to get a different monitoring stations and I have to identify how much concentration in each stations. Then I can model. So it requires a several spatial system. That is also correct. So all the above is the answer for non-point source. Okay. Yeah. Difficult to determine the dispersion rate. Difficult to monitor. That's it. Many diffuse sources. Which of the following is not an ideal practice of wastewater recycling? Not an ideal practice of wastewater recycling. That is, after treatment, how can we recycle? Which is not an ideal practice they are asking. So, use of treated domestic wastewater for horticulture. Discharge of treated domestic sewage in agricultural field. Use of treated industrial effluent in cooling towers. Discharge of domestic sewage into agricultural channels. For irrigation channels. So industries, they are using in their cooling towers. That is correct actually. Because industries can reuse their water, treated water in cooling towers. That is correct. They are doing. Treated domestic water for horticulture is good. They are doing. Discharge of treated domestic wastewater into agricultural field also we are doing, because that is one of the option. In US EPA, US EPA guidelines for discharge of wastewater in Schedule 7, if you see, there is 4 categories of discharge of wastewater. One is in the inland, one is in the sewer lines, one is in the agricultural field, one is in the marine discharge. So if you think about how much BOD should be there, how much COD, these are all pollutants I am saying, how much pH should be there. If it meets, then you can discharge in the inland. If it meets this standard, you can discharge in the sewer. If it meets, you can discharge in the agricultural field. But you can't discharge in the irrigation channels because irrigation channel need to be a pure water. Okay, so option is this we are not doing anywhere. Irrigation channel is directly the channel that is carrying the fresh water. You should not directly discharge in that. Okay, I can show you the discharge standard guidelines. Let me take um, 1 second. So EPA standard schedule 6, if you see, general standards for discharge of environmental pollutants or the effluents. We have 4 categories, as I mentioned: inland surface water, public sewers, that is a sewer that is collecting water to the STPs, land for irrigation, that is called agricultural land, marine coastal areas. If you are directly discharging into the ocean or a sea, how much it should be? The suspended solid should be 100, 600, 200, based on the cooling towers and all. Temperature should be this. COD should be this. Nitrogen should be this. So all of these parameters are standardized for 4 types of discharge. Okay, so these are all basic discharge we are doing. The treated effluents. Okay, for industries we will say effluents.
What is this UPA, sir?
It's an Environmental Protection Agency.
EPA.
EPA, yeah.
EPA.
Sorry, this is Environmental Protection Act of India. It's the US EPA's Environmental Protection Agency. EPA in India is Environmental Protection Act. So this is the EPA, Environmental Protection Act. So this is the umbrella act. We have lots of act in India: Water Act, Air Act, like solid waste management rules. But all this comes under EPA in 1986. After EPA got introduced, all this, it's umbrella act, we will say, in environmental law. So all this law will come under this EPA because we need to initially after this. I think I can have a small lecture on that later if time permits on environmental laws. So I am also one of the student in National Law School of India University for environmental post. I am doing post graduate diploma in environmental law, PGDEL. You can also search. It's in Delhi University and Bangalore Law University, environmental law courses. So that is the law was initiated when the Bhopal gas tragedy happens. After that, they think about the Air Act. Later, when the plague started, they thought about the solid waste management. Whenever the diseases start spreading, like cholera and all, they thought about the Water Act. So every act has a history. Then later they have to think about the broad spectrum of environment, and the EPA Act came. So we have a Environmental Protection Act in India. Based on that, we have lots of standards and this type of rules to be followed for industries, and we have a whole like that was controlled by Central Pollution Control Board, and each state have a state pollution control board. We have TNPCB, that is the Tamil Nadu Pollution Control Board, that will directly report to the Central Pollution Control Board based on the discharge standards. Not only water, the air emission standards, water discharge standards, everything is under EPA. So they have a discharge standard, discharge options for the wastewater, as I mentioned here, Schedule 6. So based on that, we can discharge in the agricultural field, we can discharge in the inland surface waters, or in a marine system, or in the sewer lines, but not in the irrigation channels. Okay. Hope it's clear. Yeah. So 18th question is: degradation of natural aquatic ecosystem due to poor water management may lead to eutrophication, dead zones, both A and B, putrefaction. I forgot to tell you one thing, like eutrophication and dead zones are one and the same. Okay, because there are a lot of zones in the pond. Whenever there is a lack of DO, then the lake or the pond is considered as a dead zone. Okay, so we will draw a DO line. The DO will be here. That is the saturated DO. Then whenever the organic load or any nutrient, it will start reducing. After all the nutrients are consumed, all the algae will die. Again, the atmosphere will replenish the DO. So it will start increase. This is the DO at any time t. So at the time when the DO is very minimum or zero, then this zone is considered as a dead zone. We'll have an active zone, we'll have a dead zone, and we have a replenishing zone, and again we have an active zone. So these are all the zones of water bodies. So dead zone is the one will have the eutrophication condition. Okay, so dead zones where the DO or the dissolved oxygen is fully zero or a very minimum for any aquatic.
What would be eutrophication, sir? I never heard this one.
Sorry, sir.
D option. What is D option? Eutrophication. What is this?
You're talking about what is eutrophication?
Yeah, D option. D.
Dissolved oxygen.
The D option, sir. The last option. What
Putrefaction.
does it
Okay, putrefaction is
Yeah.
D option is like degradation of organic matter is called putrefaction. If you put a banana peel in the dustbin, next day you will get smell because of the degradation of the organic matter. That is called putrefaction.
Oh,
That's a putrefaction. Or in water system, you will say putrefaction. Yeah. So that is the that will not happen in any water bodies, right? Like so, the eutrophication and the dead zones are the problem with the poor management in the aquatic life, degradation of natural ecosystem. So whenever the dissolved oxygen is nearly zero, then it is called dead zone. So option A and B both are correct. Yeah, eutrophication. Excess nitrogen and phosphorus can lead to potentially toxic algal bloom. That's what I mentioned. Green layer, that is the algal bloom, and declines the biodiversity because all the fishes will die. All other organisms that requires water, like plants underground, underwater plants, are will die. So that's the decline in the biodiversity. Okay. Then, which of the following central government scheme is aimed at attaining national-wide cleanliness and hygiene? We have lots of schemes. One is based on the cleanliness and hygiene or sanitation. Swachh Bharat Abhiyan is the propaganda or what we can say. It's a propaganda, and Swachh Bharat mission is the whole mission. So you can say SBM and SBA are one and same only. Okay, SBA, Swachh Bharat Abhiyan or Swachh Bharat mission. So that's the scheme given by the government for cleanliness and hygiene in India. Yeah, in 2014 it was started.
Can't we consider Namaganga also in this?
Sorry, sir.
Namaganga also was the same thing, sir, for cleanness and hygiene of rivers. Have we considered that also in this?
Navi Ganga. What is
C option, sir.
D? Oh,
The C option which you
Namami Ganga. That I have to read. I don't know about anything on that. I have to read, sir. Maybe I will tell you in the next week.
It was for the rivers.
Yeah, rivers. But they are asking about the cleanliness and hygiene as a whole. Maybe if you are thinking about river, Namavi Ganga may be correct. That I will read and I will tell you in the next week. I don't have any idea on that. Yeah. And then constructed wetlands can be used for, as I mentioned, construction wetlands have lots of aquatic plants, and they will take all the carbon source from the wastewater, nutrients from the wastewater, also the carbon source, and it will, whenever you supply a wastewater, and it will give you a fresh water at the other end. So it will be used for water conservation or preservation of flora and fauna or wastewater treatment. All will be there. That's why wetland need to be conserved. It's a good place for flora and fauna. All you can see Vedandangal, we have a whole bird sanctuaries and all based on the wetlands only. It's coming in Tamil Nadu and all. If you see, lots of wetlands are there around the nation. So that's a place where the biodiversity is very rich. You can find all type of plants and all type of aquatic organisms as well as other birds and animals. So that's a place for preservation of flora and fauna. Also, it's a treatment system. Also, we can conserve wastewater because it's increasing the water table. So water conservation is one of the point. So all the above is correct. So usage of generated wastewater for beneficial purpose like horticulture or irrigation with no prior wastewater treatment is known as, without any treatment we are using the wastewater for horticulture and irrigation. It is called reusing or recycling or reclamation. Recycling is after treatment we are using. Reclamation is we are reclaiming something from the wastewater. But if you are directly using, that is called reuse. As I mentioned, your bathroom water or your flush water, I mean not the toilet flush, the tap water after bathing and the shower, that can be the tap water directly can connect with the gardens like horticulture or irrigation. So with that is having less organic load. So that is called reusing. Without any treatment you can do. Okay. Okay. So the non-point source pollution are easy to locate and control, easy to monitor, many in number but with small flows, all the above. It's not easy to locate, it's not easy to monitor, it's many in number but with, yeah, it's correct. It's many in number but with small flows. Many questions will be repeating because I have taken from last 3 years, but I have chosen in different forms. So it will be slightly confusing, but mostly it will be in the core concept. Yeah. Select the odd one among the following: domestic wastewater, municipal wastewater, stormwater, and sewage. I think three of these are same meaning. Domestic is domestic wastewater, municipal solid waste, municipal. I am sorry about the solid. I am again saying solid waste, municipal wastewater, and sewage. All three are the same, one and the same. Stormwater is different because we are seeing here like domestic wastewater, municipal wastewater, and sewage are same. Stormwater is the other type of wastewater. Yeah. Which of the following statement is true regarding the different types of wastewater? Generally, industrial effluent are lesser polluted than municipal sewage. Is that correct? No, industrial effluent are highly polluted. Water from agricultural sector is usually low in organic matter. No, because organic agricultural wastewater are green in color. Color coding we given green because it's having lots of organics. Water from toilets is high in chemical content but has a relatively low concentration of pathogens. That is also wrong. Then what is correct? Okay. They are asking industrial effluents are lesser polluted. That is mm, statement is true regarding different types of wastewater. Agricultural sector is having low in organic matter. Water from the toilets is highly. This is wrong. Industrial effluent that is also wrong. And water from agricultural sector is usually low in organic matter. Okay, correct. Agricultural sector will be having less organic matter compared to the domestic wastewater, and agricultural wastewater will have more nutrients, sediments, and agrochemicals, right? No, B is correct. Yeah, B is correct. You got it. Because industries are less polluted, that is wrong. Toilets having more pathogens, not chemicals, so that is also wrong. Agricultural sector is having organic, but what they mentioned, usually low organics compared to domestic wastewater. Agricultural sectors are emitting lots of sediments, nutrients, fertilizers, and pesticides, that is agrochemicals. Okay, so option B is correct. Hope you understand this. Yeah. Okay, let me move on to the next question. Select the correct order in terms of degree of pollution. Light gray, heavy gray, black water, which is having higher degree of pollution, which is having lesser degree. So based on the color itself, you can understand black water is having heavier organic load, heavy gray than light gray. Okay, so option A is correct. Yeah. Same question I am putting in different forms. So in addition to water, the wastewater typically contains water is the purest form. Why it's called wastewater? Because of the presence of organic matter, not only organic matter. Microbial pollutants will be there if it is a toilet water. If it is agricultural runoff, it may have nutrients. So all the above is correct. Okay. So water will become wastewater because of the presence of nutrients, organic matter, and microbial pollutants. That's what I told in the second slide. Select the non-point source of the pollution among the following. Can you select industrial effluent outlets? That's the point source. Pollutant deposit through atmospheric deposition. We can't find where it is coming from. So that is a non-point source. Toxic chemicals from urban runoff. Runoff is surely non-point source. Discharge from oil refineries. Oil refineries are known where it's coming from. So it's a point source. Landfill is a point source. Discharge from STPs are a point source. Nutrients from faulty septic tanks. So septic tanks, we know many households are having septic tanks, but if you find some nutrients coming out, we don't know which septic tank it is coming from, because any septic tank may have a leak or a fault. Okay, it may have a crack. So that is a non-point source. So option 2, 3 and 7 are correct. So B is correct. Yeah, correct. Okay. Yeah. So discharging untreated wastewater into water bodies may have economical impact. We have three impacts, right? One is health impact, second one is environmental ecological impact, third one is economical impact. So how it affects the economy? Utilities spend higher budget for wastewater management. We need the higher budget, right? That is also correct. Negative effect on activities like aquaculture, agriculture and tourism. That is also correct. If you have larger demand of water, then you will have larger production of wastewater. So it will again add cost in the wastewater treatment and management. Economic impacts of water bodies. Discharging, oh, I'm sorry. We have to read the question. Discharging untreated wastewater into the water bodies. So here we are not talking about the wastewater management. We are talking about discharging, how it's having impact. So if you discharge, it will have impact on the aquatic agriculture and tourism. Yeah, we don't talk about treatment as economic barrier. Sorry for that. Option B is correct. So have a direct effect on the agriculture, industry, fisheries, and aquaculture. It's not having any impact on the treatment facility. As the demand increases, we have an increasing cost in the treatment. That is on the management system, not on the treated effluent discharge. Which of the following diseases can be reduced by improving sanitation and wastewater treatment? We can reduce the waterborne diseases. What are the waterborne diseases? Dengue, cholera, diarrhea. Dengue is caused by mosquito, that is from water, stagnant water. Cholera is also from virus, that is also Vibrio cholera is that is also coming from water. All the above. I have mentioned improving sanitation may eliminate many diseases, waterborne diseases like cholera, dengue, diarrhea, helminths. So all the above is correct. The diarrhea is also waterborne bacterial disease only. Yeah. One of the primary challenges in recycling wastewater is primary challenge. We have lots of institution challenge, right? Requires treatment to produce safe water, fit for designated use. Not enough wastewater is generated. That is not a challenge. There are potential environmental risk even with recycle. No, there are no environmental risk with recycling. Adequately treated wastewater. If it is fully treated, adequately treated, then why there is an environmental risk? So this is also wrong. Requires treatment to produce safe water fit for designated use is our challenge. Okay. The challenge is not getting enough wastewater is not the challenge. But if it is adequately treated, then there is the potential. There is no potential environmental risk. If it is only partially treated, then there is a risk in recycling. Okay, so requires treatment to we need to have a proper technology to treat the wastewater that is fit for designated use. That is the challenge. I think last question. Approximately what percentage of municipal wastewater receives treatment in India? As of the latest data we have in 2018, only nearly around 70% is untreated and 30% is treated. So nearly 35% is receiving treatment in India, right? That's what we had seen in the chart also. 30% is treated, 75% is not treated. Also, if you think about the low and middle income country, there are also 35, 75, 65 is the range they have mentioned. Yeah. So think about the target. We need to at least treat 65% in for low and middle income countries. Yeah, this may be the last question. Sorry. Match the wastewater resource management option with the process implemented. Combined water and nutrients recycling, what we can do. Energy generation, what we can do. Ecosystem replenishment, what we can do. If you want to replenish the ecosystem, you have to discharge in the wetlands. If you want energy generation, you have to think about biogas or biomass production. These are all I have shown in the recycling, resource management slide. Combined water and nutrient cycle, you can use, if it's a nutrient, you can use in the agricultural field. Okay. So 1C is correct. Yeah. So that's all about today's class. So thank you so much for joining. My class will be on every Monday 6 to 8 p.m. Don't forget to give the assignments on before Wednesday. That's the deadline. Wednesday 12 p.m. maybe that 12 I think 11:59 p.m. is the deadline. So don't forget to give the assignments for the first week. I can't disclose the assignment answers. You will get the answer on Thursday itself. Okay. That I will discuss in the 13th week of the course. Before the exam, we can once discuss the all 12-week present assignments. Okay, as an extra class we can do. So hope
It contains some numerical questions as well. So I guess we have not covered today the assignment one. If I'm not wrong, it covers the numerical part as well.
this week's assignment.
What about? No, I'm talking about the assignment for week one only. Week one assignment also contains some questions on some numerical questions as well. If I'm not wrong.
No, I don't
I'll
think
just
so.
check it.
I have checked yesterday.
Okay, I'll check it again. Maybe I was wrong.
Yeah.
I have seen it for week two then.
Oh, maybe. Yeah. Week one I have given yesterday. I didn't find any numericals.
Okay.
Most of the stuff we have covered already today. So you can now check. You can easy to answer. It will be easy.
Sure, I'll do that.
So if you have any more questions, you can unmute and you can ask, or you can put it in the chat box. I will be in the meet for next 5 minutes, or you can put it in the Q&A forum in the platform, Swayam platform. That also I will answer frequently. You can contact me through my mail, and you can follow me on LinkedIn also if you want. So thank you so much for joining. Other scholars are also taking parallelly on Tuesday 68 and Saturdays. I will be taking the 1 hour session and 1 hour problem solving. If you like my class, you can join in Monday 68. Okay. Thank you so much. You can leave the meet now. Yeah. If you don't have any question, you can leave the meet now. You can find the recordings in the platform.
Thank you, sir. Thank you for that.
Thank you. Thank you all.
Thank you, sir.
Thank you, ma'am. We'll meet up next week. If you don't have any question, let me close the meet. Thank you all for joining. I'll end the meet now.